welcome to another module in this massive open online course. Alright, so we are looking at frequency translation or frequency mixing, alright, which is also known as heterodyning. Okay, so we are looking at frequency translation or mixing. Or also known as frequency mixing. Okay. And the problem with the heterodyne receiver that we have seen, a heterodyne receiver. Okay. And the problem with the heterodyne receiver is the presence of what is known as an image frequency. So, problem with heterodyne is the presence of what is known as an image frequency. Now, what is an image frequency? Now, consider the signal, incoming signal x t equals m t cosine 2 pi f 1 plus 2 f 2 f 1 plus 2 f 2 t, okay, or f 1 plus 2 f 2 t. Okay. Now, this is mixed with again cosine 2 pi f 1, again this is mixed heterodyne with cosine 2 pi f 2. So, we perform x t into cosine 2 pi f 1 plus 2 f 2. So, this is signal, this is mixing. Okay. So, this is mixed with a signal with frequency f 1 plus f 2. And now, if you observe what we get is, well, m t cosine 2 pi f 1 plus 2 f 2 times cosine 2 pi f 1 plus f 2 t, okay, f 1 plus f 2 t. Now, this is equal to half m t cosine 2 pi times the difference of frequencies f 1 plus 2 f 2 minus f 1 plus f 2. You can see that it again gives the difference f 2 t, correct, plus cosine the sum of frequencies f 1 plus 2 f 2, f 1 plus f 2, that is 2 f 1 plus 3 f 2 into 3 f 2 t. Now, if we band pass filter this, signal with the band pass filter at f 2 of suitable bandwidth, what you can see is we can extract the cosine 2 pi f 2 t component. Okay. So, now after band pass filtering, with center frequency after band pass filtering with center frequency f2, what we obtain after BPF, what we obtain is half empty cosine 2 pi f2t. Okay. So, therefore, what you can see is previously we had seen that the frequency f1 is translated to f2, but there is also an image frequency f1 plus 2f2 which will also be translated to f2, and therefore, naturally this signal, if there is an incoming signal at this image frequency f1 plus 2f2, all right, if there is an incoming signal at this image frequency f1 plus 2f2, that is also going to interfere, that is going to be translated to f2 and hence interfere with the signal at incoming signal at frequency f1, which is also being translated to f2. Okay. So, there is, so we have, so therefore, carrier frequency f1 plus f1 plus 2 f2 is also translated to, and this f1 plus 2 f2, this is termed as the image frequency corresponding to, this is the image frequency. The image frequency, your image frequency this is the image frequency corresponding to f1. Okay. This is also termed as your image frequency. Okay. This is the image frequency corresponding to f1. Okay. So, that is the problem. All right. For example, let us take an example. Okay. Consider an FM station or consider an AM station, AM radio station operating at f1 equals, let us say this is operating at f1 equal to 600 kilohertz. We choose an intermediate frequency IF equals, well, intermediate frequency. Okay. Remember, IF stands for intermediate frequency. So, intermediate frequency, that is your f2 okay. Now, therefore, the mixing frequency of the locally generated oscillator, this implies the mixing frequency of your this should be, well, that is f1 plus f2, which is equal to, well, your AM station has 600 kilohertz plus intermediate frequency is 455 kilohertz, both these are in kilohertz, which is equal to, well, 1055 kilohertz. this is the frequency of the, this is the oscillator frequency of the heterodyne. Okay. This is the local oscillator frequency of the heterodyne, correct. However, there will also be an image frequency which will also be shifted to the same frequency, intermediate frequency 455 kilohertz, all right, as we have seen. And what is that image frequency? Now, the image frequency corresponding to this, the image frequency that is f1 plus 2 f2 that is equal to 600 kilohertz, well, plus twice into 450 2 f2 twice into 455 kilohertz. Okay. So, that will be your 1510 kilohertz. So, this is the image frequency 1510, this is also shifted to. So, incoming signal with this also shifted to 455 kilohertz. Okay. So, therefore, that is the problem, that is an important aspect of the heterodyne receiver, all right, and therefore, to avoid this problem of the incoming signal at an image frequency interfering with your desired signal, the incoming signal has to be appropriately RF pre-filtered, all right, pre-filtered in the radio frequency, all right. So, one has to array or one has to design an appropriate RF pre-filter to remove the signal at the image frequency. Okay. So, this has to be removed. So, to avoid interference, so image has to be image frequency signal, image frequency has to be suitably attenuated by an RF pre-filter before mixing. Okay. So, the image filter has to be attenuated by an RF filter, otherwise it is going to interfere with the desired signal which has been translated to the intermediate frequency. Okay. All right. So, that is the problem with the image frequency. Now, realize that in the heterodyning, also note that we have used f1 plus f2 in the heterodyne, that is the frequency of the locally generated oscillator frequency, all right, frequency of the locally generated carrier wave. Okay. Now, realize that one can also use f1 minus f2 where f2 is the intermediate frequency. So, also note that f1 minus f2 can be employed for mixing. For example, consider once again x t equal to m t cosine 2 pi f 1 t. Now, this is mixed with x t I f f 2 is the same. So, we are mixing with cosine 2 pi f 1 minus f 2 t, which gives, well, mt cosine 2 pi f1 t into cosine 2 pi f1 minus f2 t, and what this gives is half mt cosine 2 pi f1 t cosine 2 pi f1 minus f2 t, that is cosine 2 pi. Okay. So, f1 minus f2, so that will be your basically cosine 2 pi f2 t minus cosine 2 pi sum of the frequencies, that is 2 f1 cosine 2 pi 2 f1 minus f2 t. Okay. And now again, once again, if you band pass filter at f2 employing, now if you band pass filter at center frequency f2, this will yield half mt cosine 2 pi f2 t. That is basically employing f1, that is mixing with f1 minus f2. Also one can translate a signal, incoming signal with carrier frequency f1 to the intermediate frequency f2. Note that this is also translated to f2. Okay. Now, therefore, there can be two frequencies, either f1 minus f2 or f1 plus f2. If f1 minus f2 is employed, it is known as a heterodyne. If f1 plus f2 is employed, it is known as a super heterodyne. That is, the mixing frequency is greater than the frequency of the incoming signal. Okay. So, if mixing frequency equals f1 minus f2, which is lower than f1, all right, this is termed as a heterodyne. Okay. Now, if mixing frequency, the more popular version, if the mixing frequency equals f1 plus f2, which is greater than f1, this is termed as a super heterodyne. This is termed as a or commonly also known as a super het, simply known as a super het receiver. This is commonly also known as a super het receiver. Okay, this is also commonly simply known as a super het receiver. So, if the mixing frequency is less than f1, it is, that is f1 minus f2, where f2 is the intermediate frequency, it is known as a heterodyne, and if the mixing frequency is f1 plus f2, all right, which is greater than the incoming frequency f1, all right, it is termed as a super heterodyne. All right, and super heterodyne is a very important principle because it significantly simplifies the processing of the incoming carrier signal, or processing of the incoming modulated message signal. all right, and this has revolutionized communication, the design of sophisticated communication systems, all right. So, what we have seen is this important principle of frequency translation, frequency mixing, that is heterodyning, all right. What is meant by heterodyning and how is heterodyning carried out, all right. We have seen also the problem with an image frequency, what the problem with the image frequency, all right, the existence of an image frequency which is also translated to the frequency, intermediate frequency f2, which therefore makes it necessary to appropriately pre-filter, right. So, design a suitable RF pre-filter, all right, to attenuate the incoming signal at the image frequency, and finally, we have also seen the concept of heterodyne and super heterodyne, all right. So, we will stop here and look at other aspects in the subsequent modules.